This is number 54 in Chapter 7. It looks at how we can relate velocity to wavelength. And remember, that's the de Broglie equation. And so the question reads with number 54 is that we have a 0.22 caliber handgun which fires a 27-gram bullet at a velocity of 765 meters per second. Calculate the de Broglie wavelength of the bullet. Is the wave nature of matter significant for bullets? And so we basically have a mass. The mass of the bullet is 27 grams, and they give us the velocity of the bullet as well, 765 meters per second, and we need to find the de Broglie wavelength. And in order to do that, we need to use the de Broglie equation, where wavelength equals Planck's constant over mass times velocity. And so we just want to plug in those values. Planck's constant, 6.626 times 10 to the negative 34th joule seconds. We're going to have that over our mass. Since we're talking about joules, that means our mass needs to be in kilograms so that the mass unit falls out. And then we have our velocity, which would be 765 meters per second. And we can solve for our lambda then to be equal to 3.2079 times 10 to the negative 35th meters. So that would be the de Broglie wavelength for the bullet. And since lambda is so small, wave nature is never perceived. Or never observed, and i.e. the bullet hits its target. It's very accurate. So even though one could reason out that this bullet does have a wave nature, that wave nature is so small that it doesn't affect the bullet from its trajectory of actually hitting the target at the end of the day. That's number 54.